for every extra packet of crisps, the price is going to go up by the same proportion every single time. Inverse proportion looks at something slightly differently. It's as one thing increases, the other one decreases. So a typical example of this would be on a worker's building site. If you increase the amount of people on site, the time in order to complete whatever it is they're building would decrease. So for example, if one man was building a wall and it took him 8 hours, 2 men might be able to build a wall in 4 hours. Okay, so increase in one decreases the other. Now that links into what we did last lesson in a nice little way. So on screen now, this is what we did last lesson. This was the direct proportion stuff. We said if y is proportional to x, or x to the power of n, doesn't matter if there's a power involved or not, we could write it as a formula, which was y equals kx to the n if there's a power, or we could rewrite it as k equals y over x to the power n. All we need to do for inverse is we write them as a divide instead. So the formula is going to be on the lines of, so first of all by saying y is proportional to 1 over x to the n, and y equals k over x to the n. So if it ever says write a formula, it's going to look something like this. Again, we still need to work out what the value for k is, and we can work out k by, if we take this x to the n across as a times, it's just going to be multiplying those two bits together. So it's going to be a very similar style to what we did last time, except for when we do the inverse ones, we're going to be doing divides rather than times. So what we'll do is we're going to start off by just making sure we can remember how to do the direct ones. So I have one direct question, and then we're going to go into inverse ones. So here's the direct proportion question on screen now, and it says P is directly proportional to Q cubed. P is 270 when Q is 7.5. Find a formula for P in terms of Q. And then it's a bit of a weird one. It says work out the positive value of Q when P equals Q. Okay, so let's start off with part A. So we have got, and it tells us in the question, P is proportional to Q cubed. So our formula would be P equals KQ cubed. Or if we wanted to, we could write this as K is going to equal P divided by Q cubed. Then we read the question to pull out the numbers. We know that P from the question is 270 and Q in the question was 7.5, which needs to get cubed. So we would say that K equals 270 over 7.5 cubed. So K equals 0.64. So our answer for part A would be P equals 0.64 Q cubed. Part B says work out the positive value of Q when P equals Q. So it's a bit of a different substitution to the one we've previously seen. This time what we're going to do is we're going to substitute P for Q and see what on earth goes on here. So we get Q equals 0.64 Q squared. So Q cubed. What I'll do now is I'll divide both sides by Q. If I divide both sides by Q, we get 1 equals 0.64 Q squared. Now if we divide both sides by 0.64, let's see what happens if I do 1 divided by 0.64. I get 25 over 16. I'm going to write that as a fraction because it's going to be easier in a second. Because now when I square root this, because these are both square numbers already, we can square root the top and square root the bottom. This should technically be positive or negative, but because the question said work out the positive value of Q, we can just keep it as the positive one. So it's a bit of a different question to what we looked at yesterday, but the same ideas were in there. Now the other thing I didn't see yesterday was about a direct proportion graph. So a direct proportion graph just looks like this. Okay, so if this is X along the bottom and Y up the side, if two things are in direct proportion, every graph, is this going to be a straight line? Okay, now the gradient of the straight line is going to be that value of k. So if I had drawn this for the previous question, this would have a gradient of 0.64 and so on. So if it looks like this, this is a direct proportion graph. If it's an inverse one that we're going to look at today, it looks like this. It looks like some weird curve like this. This is going to be an inverse one. So you could get questions on this. I've seen a few coming up which might just say sketch a graph. If it's direct, we want this red line, and if it's inverse, we just need to draw this curve. Okay, we'll probably see this inverse curve a few more times before we finish the GCSE syllabus. It comes up quite a lot. Right, let's now try our first proper inverse question then. And I've hopefully started off with an easy-ish one for us. It says the frequency f in kilohertz of a radio wave is inversely proportional to its wavelength w in meters. When w is 200, f is 1500. We need to start by expressing f in terms of w. Okay, so the first thing I'm going to write here is f is inversely, so that means it's going to be 1 over w. Sorry, I need to make that text smaller so you can actually see what I'm doing. So it's f is proportional to the inverse, so it's just a 1 over. If you see inversely proportional, we can write it like this. That means the formula we're going to use for today, for this question anyway, is f equals k over w, which we could also have as that. That's how we're going to work out k in a second. We just take the w across as a multiply, and it tells us when w is 200, f is 1500. So if we multiply these two things together, it's going to be a bit of a big number. We get 300,000. Put that back into our formula and we can write f equals 300,000 over w. So this is going to be the formula that we use. That's part A done. F is written in terms of w. We can work out the frequency by doing 300,000 divided by whatever the wavelength is going to be. Part B then says sketch a graph of f against w. Well, I'm not going to do that one on my whiteboard because we've just talked about it. It's going to be one of those curves which would start like here and then come down and curve round like I've just shown you a few seconds ago. So maybe let's rewind it and check what that one would look like. Part B then says the wavelength of a radio wave is 1250 meters. Calculate its frequency. So we're given w and we need to work out f. So all we're going to do now is we're going to stick into here 1250. We're going to do 300,000, that's still on screen, divided by 1250, and we get 240. So method-wise, it's very similar to what we were doing yesterday. We start off by writing it down in terminology like this. We turn it into an equation, maybe a separate equation to help us find that proportion constant. Plug in the numbers to work out it, get our equation back, and then we can use that equation for any other questions that we need. So here comes another one. It says P is inversely proportional to V. When P is 18, V is 24. Express P in terms of V. P is inversely proportional to V. So we're going to be using P equals K over V. Or if we want to work out K, we could do P times by V. And it tells us when P is 18, V is 24. So if we multiply 18 by 24, we get 432. K is 432. So our formula is P equals 432 over V. Next part of the question says, find the positive value of V when P is 3V. Okay, so we need to substitute in to this one, P equals 3V. So we're going to plug 3V into here. That gives me 3V equals 432 over V. So what we're going to do, get the V across as a times. That means we'd get 3V squared equals 432. Well, we can now divide both sides by 3. Got an idea what this is going to be. So V is going to say V squared is going to equal 144. So we need to square root that, and we do get positive on negative 12, but it says just give the positive answer. So the answer for that one would just be 12. Here's the next one. So I've put everything on here at once. Let's quickly run through it. It says the intensity, called E, at a surface is inversely proportional to the square of the distance, called R, of the surface from the light source. When E is 4, R is 50. Express E in terms of R. Then calculate the value of E when R is 20. And then calculate the value of R when E is 1,600. Okay, so let's start this exactly the same as we've done all the other ones. We're going to say E is inversely proportional to R, but it does say the square of R, so it's R squared this time. So my formula is this going to be E equals K over R squared, and if we want to work out E, we could take the R squared across as a multiply. So it's numbers, we have some numbers. It tells us E is 4 when R is 50. So we need to do 4 times by squared. That gets me 10,000. So K is 10,000. So my actual formula is going to be E equals 10,000 over R squared. So for part B and C, I can now just substitute numbers into here, calculate the value of E when R is 20. So if I know R is 20, I just need to do 10,000 over 20 squared. That's going to get me 25. 20 squared, that gets me E equals 25. And then for the next one, a bit of a slightly different rearranging one. It says if E is 1,600, work out what R is going to be. So I'm going to kind of hopefully do 2 steps at once here. I'm going to take this R squared across as a times, and then bring this 1,600 down as a divide. So I'm going to get R squared equals 10,000 over 1,600. So it looks like these two bits here have just switched places. Okay, that's fine. So I now need to do 10,000 divided by 1,600. And I get an answer. That's R squared, so I need to square root that. And I get 5 over 2, which is 2.5. And it could be positive or negative 2.5. This question does not say find the positive one, it just says calculate it. So I'm going to write R equals positive or negative 2.5. And I think I've got one more example to do. says V is inversely proportional to the square of t. V is 28 when t is 2.5. Express V in terms of t. Then work out the value of V given a number for t. So same idea as what we've been doing. V is inversely proportional to the square of t. So I'm going to write that as V is proportional to 1 over t squared. So my formula is V equals k over t squared. So I can work out k by taking it across as it times. We know when V is 28, t is 2.5. So we can work out what k is by doing 28 times by 2.5 squared. We get 175. K equals 175. So V is really 175 over t squared. Work out, that's my answer for A, work out the value of V when t is 6.25. So V equals 175 over 6.25 squared. 175 divided by 6.25 squared, and we get 4.48. Okay, so that is how we do inverse proportion. Hopefully it's made a lot of sense. It's pretty much what we did last time. So your sheet today looks very, very similar to the sheet that we did last time with direct proportion, except for it's going to be asking about inverse proportion all the time. So question 1 and 2 is just asking for the formula again. Nothing you need to do to work it out. 3 is a chunked question. So the first part is write a formula, then use your formula to work out a value of C and then work out a value of B. Question 4 is exactly the same as question 3 with different numbers and different letters. 5 is the same as the other questions except for it's got rid of the chunking. For question 6 it says question 6 is the same as question 5. Okay, and then questions 7 and 8 are the table ones again. The only slight issue is question 8. It looks like, and I can't read it because it's quite small on there, it says x is inversely proportional to either w squared or w cubed. I can't see what number it is. Okay, so I'd like you to give that sheet a go. And then when you've done that, because I don't think it'll take too long, is another kind of sheet just on these tables. Okay, it's two-sided. The first side is all about direct proportion, which is what we did last lesson, and then the second side is all about inverse proportion, which is hopefully what you're going to get the hang of today. That's it for this topic. That is the inverse, so it's the whole thing about ratio and proportion all done. That means Thursday's lesson is going to be the end of topic, and of course we don't have a lesson on Friday because it's bank holiday. So I'll probably set that end of topic to start off in that hour that we would normally have in class, and then ask it for some time over the weekend. As usual, if you've got any issues, can't answer a question, or just need a little bit of clarification, send us a message over at Show My Homework or on Microsoft Teams, and I'll get back to you as soon as I can. And I will see you all on Thursday then, when I will be going through the end of topic.